Investigate static routes. Topology. 3 routers with gigabit interfaces and serial interfaces. Go to routers section and you can use IOSB with gigabit interfaces, or also you can use Cisco 7200, this 7200 with iOS 15.2. Okay, drag this Cisco 7200. Okay, with gigabit interfaces and serial interfaces. But use three routers and connect them, R1, R2, and R3, R1, R2, and R3. Gigabit 000 and gigabit 000 between R1 and R2. Okay, I will use gigabit 00. And between R2 and R3, gigabit 001 and 000. Okay, on R2, gigabit 001 and R3, gigabit 000. On R2, gigabit, in my case, I will use 10, and on R3, gigabit 00. And serial connection 010 to 010 and 011 to 011 between R1 and R3. I will use serial 30, and serial 31 and 31 between R1 and R3. Okay. Okay, very good. And loopback interfaces. Loopback 0 on each device. The addressing table configurations with IPv4 and IPv6 R1, R2, R3. There are several different types of static routes available for you to use. You should fully understand the implications of each type of static route on the routing table and the overall routing scheme in the network. In this lab, you will configure several different types of static routes for both IPv4 and IPv6 and examine the impact of the static routes on the routing table and traffic flow in the network. Required resources: 3 routers, Cisco 4221 Real Lab. In my case, I'm using Cisco 7200. Console cables, Ethernet cables. Build the network and configure basic device settings. Configure basic settings for each router. Okay. Copy this to a notepad. The IP addresses and basic configurations. Okay. Notepad. And on R1, okay, hostname, IP domain lookup, IPv6 unicast routing, banner, line console configuration, BTY line configuration, and interface gigabit 00. In my case, on R1, I'm using gigabit 00, serial 30, and serial 31. Okay, gigabit 00, serial 30, and serial 31. So modify this loopback interfaces. Okay, and start the devices. Start R1, start R2, start R2, start R3, and R2, hostname, IP domain lookup, IPv6 unicast routing, banner, line console, the IP configuration, gigabit 00, gigabit 10 on R2, gigabit 00 and gigabit 10 on R2. Loopback interface, very good. And router R3, hostname, no IP domain lookup, IPv6 unicast router, banner, line console, line BTY. Interfaces, gigabit 00 on R3 and serial 30 and 31. Serial 30 and serial 31. And the loopback interface. Okay, R1, R2, R3. Yeah. Okay, and now go to R1, configure terminal, and on global configuration mode, paste the configurations, copy, right click to paste. Okay, very good. No issues. Okay, very good. R2, configure terminal, copy all this for R2, copy, right click to paste. Very good. R3, configure terminal, and copy this. Copy, right click to paste. Okay, hostname, no IP domain lookup, line console, BTY. Gigabit 00 does not exist. In this case, R3 is gigabit 00. Okay, so modify here. Gigabit 00, 0, serial 30, serial 31, and loop back. Okay, enter, configure terminal. Copy all again. Don't worry. Copy. Right click to paste. Okay, very good. No issues, no errors. Configure and investigate IPv4 static routes. The configuration being used here is not meant to represent best practice, but to assess your ability to complete the required configurations. On R1, configure a directly attached static route. Directly attached static route for the 192.168.20.27 network using gigabit 00 as the exit interface. Okay, on R1, this is the destination 2027. This is the destination 192.168.20.27. The exit interface is gigabit 00. So that's why it's called directly attached. So go to R1, configure terminal IP route 192.168.20. divide 27 is 224, gigabit 00, enter. Okay, this is show IP route static pipe being begin gateway and show IP route static pipe begin gateway. Okay, show IP route static begin gateway. This is your static route. As long as interface gigabit 00 is up in operational, this entry will be present in the routing table. Note that the output does not give you indication of the administrative distance or metric for this route. Okay, gigabit 00 directly connected and no administrative distance. To get details on the route, issue command show IP route 192.168.20.224. This output provides the administrative distance metric for the route, and administrative distance of 1 is the default for static routes and is the second most trusted administrative distance available. Show IP route 192.168.20, 255, 255, 255, 224. Okay, the distance is 1 and metric 0. Connected. Configure a recursive static route. Every route loop must resolve to an exit interface. When the route for a destination is configured with an IP address as its next hop, the router has to determine what exit interface to use to get to that next hop, which causes a recursive lookup. A recursive route is one that requires an additional lookup in the routing table. Cisco Express Forwarding (CEF), which is enabled by default, automatically works through the iterative process of finding the exit interface, so the CPU is not involved in that process for each packet matching the recursive route. This helps reduce latency and CPU load. A recursive static route cannot depend upon a default static route for NetScope resolution. The router must have a valid route to the intermediary network, or the recursive static route will not be inserted into the routing table. On R1, configure a recursive static for route 10230 using NetScope IP address 10122. Okay, on R1, configure route to 10230 using the NetScope IP address 10.1.2 and 10.1.2.2. For R1 to reach this subnet, the NetScope IP address is this. The IP address of gigabit 00 on R2. And go to R1, configure terminal IP route, the destination 10.230, 55.55.55.0, NetScope 10.1.2.2. 2.2. Enter. Very nice. Show IP route static begin gateway and show IP route static begin gateway. Okay, two static routes. Notice the entry for 10.230 does not list an exit interface. This indicates that a recursive lookup is necessary. Okay, this is the route 10.230, administrative distance 1, metric 0, via a NetScope IP address. Command show IP route 10.230 255.255.255.0 and examine the output. Show IP route 10.230 255.255.255.0. It shows all the information expected for a static route, an administrative distance of 1 and a metric of 0. Once again, the output does not show a NetScope address. Under non-Cisco Express forwarding conditions, the router would have to do an additional route lookup to decide how to reach the NetScope IP address 10.1.1.2. Okay, static administrative distance 1, metric 0, and this is NetScope IP address. Issue the command show IP CEF 10.230 255.255.255.0 and examine the output. Show IP CEF Cisco Express Forwarding 10.230 255.255.255.0. Enter. Here is where we see that Cisco Express Forwarding has stepped in and solved the NetScope question for us, which means the router, in this case, will not have to perform an additional route lookup. This saves time and CPU cycles. Okay, the NetScope 10.1.2.2 using the local interface gigabit 00. Okay, on R1 to reach 10.230, we'll use the NetScope 10.1.2.2. the interface, the local interface on R1 is gigabit 00. The local interface is gigabit 00 for R1. And on R1, configure a fully specified static route. A fully specified static route is configured using both the exit interface specification and the NAT hub IP address. The route is only valid if the exit interface is up. A fully specified static route is preferred so that recursive lookups do not result in routing decisions that might add latency to the path. Remove the static route you had created for 10.2.3.0.24 network and add a fully specified static route using interface gigabit 000 as the exit interface. Okay, on R1, configure terminal and remove the previous configured static route and add the keyword no to remove, and the same command IP route 10.2.3.0 let's hop 10.1.2.2 enter. Okay, now is removed, and now add the new and will be IP route 10.2.3.0 subnet mask, the local interface gigabit 00 in my case, 00 in my case, and the NAT hub IP address. Okay, enter. And now show IP route begin gateway. Okay, show IP route static pipe begin gateway, and now you can see the static route, the destination network, administrative distance 1, the NAT hub IP address 10.1.2.2 and local interface gigabit 00. Both. The NAT hub IP address and the local interface. And now show IP route 10.2.3.0 and subnet mask. Okay, show IP route 10.2.3.0 285.285.285.0. It also shows that 10.1.2.2 is reachable via gigabit 00. Okay, the entry is 10.2.3.0, is a static route, distance 1 metric 0. Okay, distance 1 metric 0, and let's hop IP address 10.1.2.2, local interface gigabit 00. Configure and floating static routes. Floating static routes typically provide secondary or backup to primary link. By default, static routes have an administrative distance of 1 and directly connected routes have an administrative distance of 0. Directly connected routes are seen in the routing table with the code C or L, with the administrative distance of 0 is shown below. For example, show IP route 10.1.2.1. Okay, this local interface on R1 10.1.2.1. Okay, on R1 is the directly connected network, is a local interface IP address, and show IP route 10.1.2.1. Administrative distance 0, metric 0. Okay, you can see the prefix for the host IP address on the interface is 32. Okay, the subnet mask or prefix is 24 for this interface, but for a single host the prefix is 32. So that's why you will review the network address, the directly connected network address. This was the local address for L is a host IP address on the interface gigabit 000, host IP address on the interface gigabit 00. But now you will see the network address on the gigabit 00. And you will use show IP route 10.1.2.0 and the subnet mask 285.285.285.0. Okay. Network address, local interface gigabit 00. Okay, administrative distance 0, metric 0. A floating static route is a static route that has been assigned a higher administrative distance than the default. The classic use case for a floating static route is to provide backup to a dynamic routing protocol. For example, the administrative distance of OSPF is 110. As long as OSPF is working, destinations are reachable. But what if OSPF fails? Adding a floating static route with administrative distance of 112 would allow that route to be inserted in the routing table as soon as OSPF fails, and then be removed as soon as OSPF is restored. The key benefit to this, the traffic continues to flow. For this example, we will consider the connections between R1 and R3. Normally, when there are multiple direct connections between two routers and those connections are included in routing, we can expect equal cost load balancing to occur. In this case, we are going to manually control which connection is used so that we can demonstrate a floating static route. Configure a fully specified static route to the 192.168.3.0.27 network using the exit interface serial 30 and NetHub 10.1.3.3. Okay, the destination on R1, the destination 192.168.3.0 prefix 27, serial interface 30 in my case, NetHub 10.1.3.3. Okay, on R1, the destination will be, this is the destination 192.168.3.0 prefix 27, and the NetHub IP address 10.1.3.3. This is the NetHub IP address. And the local interface serial 30. Configure terminal IP route 192.168.3.0.285.285.224. And local interface serial 30 in my case. To reach this, my local interface serial 30 and NetHub is this 10.1.3.3. Space 10.1.3.3. Okay, enter. Show IP route static begin gateway to verify. And show IP route static begin gateway. And this is the static route. Destination network, NetHub IP, local interface. Configure another fully specified route to the 192.168.3.0.27 network, but this time use the exit interface serial 31 and the NetHub 10.1.3.130. Okay, so create another route to the same destination 192.168.3.0.27 and the local interface serial 31 and NetHub IP address and NetHub IP address 10.1.3.130. Okay, configure terminal. The same destination 192.168.3.0.224 Local interface is serial 3.1 and next hop 10.1.3.1.30. Okay, enter. Okay, verify with this command and show IP route static begin gateway. Okay, and you will have for the same destination 192.168.3.0 you have two paths using this net hop 130 and local interface serial 3.1 another path net hop 3 and local interface serial 3.0. So you have two paths to reach the same destination. Look more closely at the route 192.168.3.0.27 network and you can verify how the router is going to load balance between the two paths. The traffic share count for each of the routes tells you the number of packets that will be sent using the referenced route. In this case, the serial 3.0 path will get one packet and then the serial 3.1 path will get one packet. Show IP route on R1. Show IP route 192.168.3.0 prefix 255, subnet mask 255, 255, 255, 224. Okay, the first part traffic share count is 1 and the second part traffic share count is 1. So there is no preference. This is load balancing. Load balancing between serial 3.0 and serial 3.1. Now you will adjust this so that the serial 3.1 path is standby. You will do this by deleting the current route that uses serial 3.1 as an exit interface and adding another static route via serial 3.1, this time adding the administrative distance of 7. Okay, remove the previous configuration on serial 3.1, configure terminal. Remove this IP route with no keyword, no IP route 192.168.3.0. 224 serial 3.1 in my case. And let's hop 130, enter, remove this. Okay, remove the route using serial 3.1. But add the same route, but at the end add administrative distance of 7. IP route 192.168.3.0 to 24 serial 3.1 let's hop 130 and administrative distance of 7. Enter. And now verify. Show IP route static begin gateway. And now only one path is available using serial 3.0. The administrative distance of this route by default is 1, and the another is not present because the administrative distance is higher, is 7. You will see there is only one route, 192.168.3.0, in the routing table. Okay, and go to show IP route. Show IP route 192.168.3.0, subnet mask 224, and only one route using serial 3.0. Okay, serial 3.0. Shutdown command on interface serial 3.0. Then examine the routing table again. You will see that the route using serial 3.1 is in the routing table and operational with administrative distance specified 7. Okay, and shut down the preferred interface, shut down serial 30, configure terminal interface serial 30, shut down. Okay, and show IP route static begin gateway. And finally, you will see one route to 192.168.30, administrative distance 7, with the next hop is 130 and local interface serial 31. Local interface serial 31, next hop 130, administrative distance 7. Okay, is the backup. The backup is present when the primary interface is shut down. Show IP route, next hop 130, local interface serial 31, administrative distance 7. When serial 30 recovers, it is automatically pasted in the routing table, and serial 31 path is removed. Okay, configure terminal. So enable interface serial 30, shut down, and wait for the interface up, protocol up, verify, show IP route static begin gateway, and now automatically serial 30 with nethop 3 is present. On R1, configure a null static route. Another type of static route that provides a great deal of utility is the null static route. Using the null static route, you can insert routes into your routing table for destination prefixes that you do not actually have a path for. This allows you to basically drop traffic destined for specific prefixes. The null route can also insert summary routes into your routing table so that dynamic routing protocols can advertise them, while your router routes are based on more specific prefixes within that summary. You will install a null static route just so that you can see it in the routing table and what information the router can show you about it. On R1, configure a null static route for the 209.165.200.0.24 network. On R1, configure terminal IP route 209.165.200.0.25.25.25.0, null 0, enter, and verify. Show IP route static route. This new static route directly connected null 0. Take a closer look at the route using show IP route. The route has an administrative distance and metric. The router will send packets destined to this network to the null interface, which is basically throwing them away. Okay, show IP route 209.165.200.0.25.25.25.0. Okay, administrative distance 1, metric 0, directly connected null 0. Configure and investigate IPv6 static routes. You will configure and examine the different types of static routes available to IPv6. The good news is that all the same types of static routes are available. One thing to keep in mind is that if the nethop address is a link local address, the only type of route you can use is a fully specified static route. All of your work will be on R3. Once again, the configuration being used here is not meant to represent best practice, but to assess your ability to complete the required configurations. On R3, configure a recursive static route. create create a route to 1012 prefix 64 network via 10232. Okay, you are on R3 and create a static route to 1012 using the NetHub IP address 10232. Go to R3, configure terminal IPv6 route 2001 DB8 ICAD 1012 is the destination. NetHub IP address 2001 DB8 ICAD 1023 : 2, the NetHub IP address, and verify show IPv6 route static. Okay, show space IPv6 route static. And okay, and the static route is not present because I made a mistake. This should be 2001. Okay, remove this and use the correct route. Configure terminal. Remove the previous IPv6 route 2001 and use the same command, including the mistake. Enter and add the correct IPv6 route 2001 DB8 ACAD 1012 64 2001 DB8 ACAD 1023 : 2. Enter and verify. Show IPv6 route static. Now, and you can see static route destination, administrative distance metric, and NetHub. Examine the details. Show IPv6 route 2001 DB8 ACAD 1012 : prefix 64. Okay, column. Enter. Okay, the destination, static, administrative distance metric, count, routing paths, NetHub IP address, examine CEF, Cisco Express Forwarding details with the command show IPv6 CEF and the destination and detail. Okay, show IPv6 CEF, the destination address, the destination network address, and detail at the end. The destination network, the NetHub IP address, and the local interface gigabit 00. Okay, on R3, to reach this subnet, this network, and using this NetHub IP address, you will use local interface gigabit 00. On R3, configure a fully specified static route. You will do something a little different and use link local address as the NetHub IP address. This is not a common requirement, but it differentiates this from the fully specified IPv4 route. What is the neighbors link local address? You can see this for Ethernet interface using show IPv6 neighbor. Neighbors do not appear on serial interfaces. On R3, show IPv6 neighbors. Okay, show IPv6 neighbors. The IPv6 address of the neighbor, the IPv6 address of gigabit 10, the IPv6 address of gigabit 10 on the neighbor R2. Okay, the IPv6 on the neighbor R2. This is the global unicast address, and this is the link local. Okay, the link local also for this interface gigabit 10 on R2. Remove the recursive route you configured earlier and replace it with a fully specified static route using the link local address of R2 as the NATS hop IPv6 address. Okay, and remove the on R3 configure terminal. Remove the previous recursive static route. Now IPv6 route 10.12.64 and NATS hop 10232. Enter. Now you remove it, and now specify a fully specified IPv6 route with the same destination, the local interface gigabit 00, and the link local address is the NATS hop IPv6 address. Okay, on R3, IP route to this destination network 1012. The local interface is gigabit 00, and the NATS hop, the link local address of gigabit 10 on R2. Okay, configure an IPv6 route to the same destination 10.12.64 and specify the local interface gigabit 00 and NATS hop IP address FE80 column 2 column 2. This link local address on the neighbor R2 on R2. This link local address. Enter and verify. Show IPv6 routes static. And you can see the destination, administrative distance metric, NATS hop IP address, the link local address on the neighbor, and local interface. View the detail. Show IP route, the destination 1012. Enter column prefix 64. Okay, here slash is missing. Okay, and now you can see 1012 static count NATS hop local interface. On R3, configure a floating static route. Create a static route towards 1000 prefix 64 and NATS hop 10131. And the exit interface is serial 30. Okay, this is the destination network. You are on R3 and the destination is 1000. This network is the destination. The NATS hop IP address will be 10131 using serial 30. The local interface serial 30, NATS hop 10131. Configure terminal IPv6 route. Okay, IPv6 route. The destination 1000 64. Local interface serial 30. NATS hop IP address 2001. DBA ACAD 1013 column 1. Okay, enter. And create another static route towards 2001 DBA ACAD 1000, the same destination. And NATS hop IP address is different, 1014 column 3. Exit interface serial 31. An administrative distance of 17. Okay, use this configuration. Okay, you are on R3, the destination is the same, 1000, but use the another path, the NATS hub 1014 and local interface serial 31. Okay, the same destination, the another interface serial 31, and different NATS hub 1014 column 1. And don't forget the administrative distance of 17. And verify show IPv6 route static, and only one route is present using serial 30 because it has the lower administrative distance of 1. The destination, the NATS hub IP 10131, and local interface serial 30. Okay, and now shut down the active interface, shut down serial 30, configure terminal interface serial 30, shut down, enter, and now wait a moment, interface in down, protocol down, show IPv6 route static, and now you can see the destination 1000, administrative distance 17, NATS hub is different 10141 on serial 31. Okay, this is the new path automatically on the routing table. And enable the interface. Okay, configure terminal serial 30, not shut down, and interface up, protocol up, verify, show IPv6 route, automatically re-establish it, administrative distance 1, 10131, serial 30. And configure a null static route, create a null static route to the 33364 network. Okay, configure terminal IPv6 route 3333 colon prefix 64 null 0, enter, and verify show IPv6 route static. This is the null directly connected, administrative distance 1, and view the detail, show IPv6 route 3333 colon prefix 64. Okay, and static distance 1 metric 0 count directly connected null. Complete static routing challenge. We have not configured routing on all 3 routers, nor have we tested any of the routes. Your challenge is to configure R1, R2, and R3 with static routes that provide full reachability in the network. You will be successful when you can ping any interface in the network using the ping command while specifying the source interface of loopback 0. Okay, go to R1, show IP route, show IP route static. Okay, you configured a route for 10230, 10230. Okay, already configured for 192.168.2.0, 192.168.2.0. Very good. And for 192.168.3.0, for 192.168.3.0. Okay, for these three routes, show running config to review the backup configurations. Show run space. Okay, the route for 10.2.3.0, the route for 192.168.2.0, route for 192.168.3.0, and in this lab, in this activity, if you will use the serial interface, create a backup. Okay, create a backup. Is created with administrative distance of 7. If the directly connected networks for R1 are 1, 2, 3, and 4 directly connected networks, the remote networks are 1, 2, 3, and using the backup 4, you should have on R1 you should have 4. 1, 2, 3, 4. So for IPv4, the configuration is completed on R1. Hit configure for IPv6 space, configure terminal, IPv6 routes. The remote networks start with this 2001 DBA ACAD 2000 column prefix 64, and I will use a recursive with NetHub IP address. This IP address, okay, on R1, use this IP address 200.2001 DBA ACAD 1012 column prefix 60 is number 2. Okay, enter. Now to reach this network 1023, okay, another remote network 1023. The destination is 1023, and NetHub, the same path, the same NetHub IP address 2001 DB ACAD 10122. Okay, enter. And now to reach this network 3000, to reach 3000 NetHub, you can use the NetHub IP address, in this case 10133. 1013 and 3. Okay, recursive is not fully specified, is recursive 133. Okay, by default administrative distance of 1, and the backup 3000, but use the another is 10143. 10143. Okay, and don't forget administrative distance of 17 in this case. Higher than 1 is enough. I will use 17. Okay, enter. Okay, now you have 4. Very nice. And go to R2. Show IP route, static. No IPv4 static routes, so configure on R2. Static routes to remote networks. Configure terminal IP route. Okay, first start with this loopback 0. 192.168.10.27. Okay, on R2. 192.168.10.27 is 224. I will use recursive NetHop IP address. And NetHop IP address is 10.121. 10.121. 10.121. Enter. Okay, for this 10.130.25. 10.130.25 is 128. As the NetHop IP address, you can use this or this. In this case, I will use this. 10.121. 10.121. The same NetHop IP address as the previous route. 10.121, 10.121. Enter. For this another 10.13128.25. 10.13128 and 25 is 128. And NetHop, you can use this or this. Okay, for R2, the NetHop, you can use this or this. I will use this another 10.2.3.3. 10.2.3.3. 10.2.3 and 3. Okay, enter. And finally, for this 192.168.30.27. 192.168.30.27 to 24, and use this NetHop IP address 10.2.3.3. 10.2.3.3. Okay. 4, that is enough. And do show IPv6 route. These are the directly connected networks, not static routes. Do show IPv6 route static. No static routes on IPv6 and configure that. First for 1.0.0.0.64. IPv6 route 2001 DBA ACAD 1000 prefix 64. Prefix 64. And NetHop IP address. Use this. Okay, a direct path 10121 10121 2001 DBA ACAD 1012:1. Okay, recursive, enter. Now for this 1013. 1013, and use the same NetHop as the previous route. And for this another 1014. 1014. You can use as the NetHop this or this another. I will use this 10233. 10233. 10233. 10233. Enter. finally to 3000. The destination 3000. Let's hop 10233, enter. Okay. The destination 3000 and let's hop 10233. Okay, very good. Okay, for our four IPv6 addresses. And now, finally, on R3, the last configuration, show IPv6 routes, static, and first show IP route static for IPv4 first. Now IPv4 addresses, you need to configure terminal IP route. Okay, now first for this 192.168.20.27, 192.168.20, the network address 285, 285, 285, and subnet mask 224 is 27. Let's hop IP address. I will use a recursive 10232. 10232. 10232. Okay. Enter. This another 10120. 10120. 24 is 285, 285, 285. Let's hop IP address. You can use the same. This 10232. Okay, on R3. 10232. Okay, enter. Okay, and now for 192.168.10.27. 192.168.10.27 is 224. And let's hop. I will use this one 10131. 10131. 10131. Okay. And don't forget the backup using the another link to the same destination. One 192.168.10. 224 is 10.1.3 129. 10.1.3 129. 129. 10.1.3 129. And don't forget the administrative distance for the backup 7. Use a higher number than 1. You can use 2, 3, in this case 7. Okay, and now you have 4 IPv4 routes. And do show IPv6 route. Show route static. Through static routes, review the backups with show running. Do show running config. Do show running config. Space. Okay, for IPv6, you have a route for 1000. Okay, this. The backup for the same destination. Okay, the backup is the first with administrative distance 17, but the primary path is this another, and you have a static route for 1012 1012. Okay, for this 1012, and now you need to configure, and it's missing static root for 2000. IPv6 root 2001 DB8 ACAD 2000 column prefix 64. Let's hop IP address. The recursive I will use 10232 10232 2001 DB8 ACAD 1023 column 2 10232 10232. Okay, enter. And now you have 1, 2, 3, and 4, because this is the null. Okay, now from R1 trace root 192.168.3.1 source loopback 0. Okay, go to R1 and trace root 192.168.3.1, and the source is loopback 0. Okay, success. Show nets hop 10.133. 10.133. Very nice. On R1, shutdown serial 30. On R1, configure terminal interface serial 30. Shutdown. Okay. And trace route to the same destination, same loopback. Okay, repeat the previous trace route, enter. Okay, success. This takes time, but repeat. And now you got should succeed, and let's hope 10.1.3.130. 10.1.3.130. Pass yes. No shutdown to enable the interface. Conf terminal CL30. No shutdown. And now from R2, go to R2. And ping loopback 0 on R1, 192.168.1.1 source loopback 0. Ping 192.168.1.1, the source is loopback 0. Success. 192.168.3.1. 192.168.3.1 loopback 0. Enter. Success. Okay. Pass on R3 and trace route to 192.168.1.1 source loopback 0. Trace route 192.168.1.1 source is loopback 0. Okay, trace route. Okay, very nice. Let's hop 10.1.3.1. 10.1.3.1, very nice. Shutdown serial 30. Configure terminal interface serial 30. Shutdown. And repeat the previous command. Repeat the previous command, trace route 192.168.1.1 source loopback 0. Okay, success. Let's hop 10.1.3.129. 10.1.3.129, very good. Okay, don't forget to enable the interface. Computer terminal, interface here 30, not shut down, and on R3 ping loopback 0, on R2 ping 192.168.2.1, ping 192.168.2.1, source loopback 0. Success. Now go to R1. Now test IPv6. Trace route 2001 DB8 ACAD 3000 colon 1. Source is loopback 0. Okay. Enter. Okay, it's not supported. Okay, trace route question mark. Okay, source is not supported, but only use trace routes. Enter. Success. The NAT hub should be 10131. 1013. In this case, 3. This should be 3. The NAT hub, because to reach this destination from R1, to reach this destination, you will use NAT hub 3, colon 3, or colon 3. One of those should be, okay, so this should be 3. So this is very good, and also this. Now on R1, shut down serial 30. Configure terminal, interface serial 30, shut down, and repeat the previous trace route. And the NAT hub should be 10143. 10143. Very good. Okay, it says 1, but it should be 3, because if you are on R1, the NAT hub should be this colon 3, or this another colon 3. Okay. Not shut down. View terminal, serial, not shut down, and on R2, go to R2. Ping 2001 DB8 ACAD 1000 colon 1, source loopback 0. Okay, success. Okay, ping 30001, ping 30001, source loopback, success. On R3, trace route. Okay, trace route 2001 DB8 ACAD. Okay, to 10001. 1000 colon 1, and source is loopback 0. Okay, enter. Source is not supported on trace route on IPv6, only use trace route. Very good. NAT hub should be 10131. 10131. Very nice. And shut down serial interface. Configure terminal, interface here 30, shut down, and repeat the previous trace route to the same destination. Success. And NAT hub should be 10141. 10141. Very good. Okay. When you are on R3, the NAT hub is 10131 or 1014 colon 1. Very nice. Okay, 10131, 10141, very nice. And finally, on R3, ping to R2 loopback. Ping to 001 ACID to 0001 source loopback 0. Success. Thank you very much.